Hi everyone, welcome to the tutorial on React Native. In this session, in the first half of the session, I want to highlight the importance of mobile development. And in the second half of the session, I'll be doing an introduction to React Native. So let's get started. So what is React Native? So to define what is React Native, you can use this one sentence. Like React Native is an open source framework developed by Facebook that allows developers to build mobile applications using JavaScript and the React library, enabling them to write code once and deploy it on both iOS and Android platforms. So here, the good thing is you can do the mobile development using JavaScript. Since almost everyone know JavaScript and you don't have to learn anything like a new language. Also, JavaScript is like one of the easiest language to learn. And also you can apply the same React concepts that you may already know. And another advantage of React Native is for example, if we are going to build both the iOS and Android native apps, you have to since those are two different platforms, you have to maintain like two code bases. But if you are using React Native, it's like one code base that you can deploy it on both iOS and Android. I would say about like more than 95% of the code you can reuse the code across these iOS and Android platforms. So React Native, actually, it's like a pretty popular network. So many big companies use it for building their mobile applications. I have listed some of the popular apps here: Facebook, Shopify, Discord, Tesla app, Pinterest, and Walmart. And also I included this app, which is, it was created by like ConceptVines, us, for the client carry. So I'll be playing a small demo showing like what you can achieve, what you can build with React Native. So here I'm running the app on, actually these are two like videos showing the app. Here's the Android phone, here's an iOS phone. So this app is built using React Native. You can see like the performance is very decent and UI is like decent. You compare iOS with Android, both has like same UI stylings. Also, using React Native, you can access all the device native features such as camera, push notification, GPS, and like biometric authentication, and many more. So here I included some stats. I grabbed from stat counter to show you the importance of mobile app development. So in this graph you can see the operating system market share, how it changed across the time span of 10 years. If you see back like 10 years ago, those days the smartphones, mobile phones were not that popular. So those days the Windows was the most popular operating system. So but but like eventually the mobile devices like can like cheap, affordable, and included like more features, and like there were more apps, so they got popular, and eventually fast forward into like 10 years, you can see now the most widely used operating system is Android, and also the iOS has like a decent share as well. So, and if you compare the mobile operating systems, you can see Android is like about 1/3 of the users use Android, and about 1/3 mobile users they use iOS devices. And there are like small percentage for like operating system like Windows. You can like even ignore those. So here, what I'm trying to highlight is like when it comes to mobile app development, it's not like it's equally important to target both iOS and Android operating devices. So although this is the like the global average for the mobile operating system market share, in regions like US, it's different because like more users are using iOS devices than Android. So also here, like I'm showing like this graph shows what sort of devices that Facebook users are using. As you can see, like most of the traffic is coming from mobile devices, and like more importantly from the mobile app. So let's say you came up with an awesome idea of a product or a system. Let's say it's like can be either like a new social media platform or a new selling platform. So you might be thinking like how users can access your system, like how to build the interface. So there are like two ways you can do it. Either you can build a website or an app. Actually, it depends on the your target users and like how they are going to interact with you. If we are going to, for example, if we are going to build like a new social media platform, then it might be more beneficial to create a mobile app first. So, but if you are going to build like a system, only few users access and like more like administrative stuff, then you can like simply ignore the mobile app, like build only the website. So, but if you have like no idea about the user, the target user base, then you can start with the website, and then later you can extend it with the mobile app. So, website versus mobile app, like those are like its own pros and cons. The advantage of website is like it runs anywhere, like as long as you have a browser which can connect to internet, you can access the system. And also it might be cost low because like you can easily find a web developer, and also even you can use some online tools to create websites. On the other hand, if you compare a mobile app versus a website accessing a mobile browser, you see that the mobile app perform better. Also, like it has more access to device native features, as I mentioned, like biometric authentication, push notifications, camera, GPS, mic, and everything. Also, like compared to the web app, like it gives you like the UI is like performing better. The UI is good, like it's interactive and intuitive. And also compared with like websites, mobile apps has like is secure because like you don't have those vulnerabilities that exist on the web. So let's say you decided to build a mobile app like sooner or later. So then you need to decide whether you are going to build native apps or cross-platform apps. So actually, this depends on two factors like the performance you need and the UX. For example, let's say you want every bit of performance that the device can give, and also if you want to the UIX to be perfect, then you have to use native. Otherwise, you can go cross-platform because and based on this decision, the cost and the time to market will change. The native, if you go native, the cost is high and it will take more time to build two apps. That's because, let me explain why is that. So if you use native, then you have to use a platform-specific programming languages and tools. When it comes to Android, you have to use Android Studio and you have to use the Kotlin language. And when it comes to iOS, you have to use Xcode and the Swift to separate code bases. I mean, no reusable code, but it gives you like the best performance and the UX. So on the other hand, cross-platform, it's like one code base, although it's not like, but like it's like gives you a native like look and feel. And also the performance is like very decent. So since you have only like one code base, it reduces the development and the maintain cost. So after you decide like native cross-platform, let's say you decided to use a cross-platform tool, then if you do a research, you will find that there are many tools available. So I have listed the three most popular tools you can use to build a cross-platform mobile apps: React Native, Flutter, and Xamarin. So this graph shows like over time how like the popularity change. As you can see, Flutter is like gaining the popularity very fast, although like React Native is like has lost its popularity a bit. It's still a widely used tool. So this Cordova and init, like those are not true cross-platform tools, so you can like ignore those. And the third one is the Xamarin. You can, again, it's .NET based. You can like even ignore it. So back to the original question, like, should I build a website or app? And if it's an app, native or cross-platform. So let's say you took the decision. I mean, you select the tech stack like this. You build the web using Angular framework and you need to like native apps. So Android app, so you have to build using Kotlin and Java. iOS app, you have to build using Swift and Objects, FJCC. The problem here is like you need to manage three teams because like it's very rare that like one person can have this like all the skill set needed: Angular, Android development, and iOS development. So, but if you decided your tech stack differently, for example, let's say you decided to build the web app using React and the mobile app using the React Native, then even one team should be enough because like although like React and React Native, it's a bit different, but those two use the same React concepts. So even like React web developer can like spend few days and come to up speed on React Native. It's not that difficult. So depending on the like initial decision on the tech stack, so it has like an immediate and long-term complications. Also, there's another reason to select React Native because it has a very rich ecosystem. When it comes to tutorials, you can like find a lot of online resources to learn the platform. Also, there's like a lot strong community. Also, you can find a lot of boilerplate code. You can like copy and paste and use in the app. Also, there are like many UI frameworks which gives you like all kind of UI elements you need, so that you don't have to like build any UI components from the scratch by yourself. Also, there are like tons of third-party React Native plugins. Also, it has some like very useful debugging tools, and also you can write some test cases, test automations easily. So since this React Native is based on React concepts, it's important to learn the React concepts first. So you may already know those stuff, but anyways, let me go through those quickly. So React is a library for web and building for web and native user interfaces. This is like a very easy to learn because it's based on JavaScript. Also, for creating UI templates, you can use JSX. Also, this React, it's like based on component. It follows a component-based architecture, and it's give like a good rendering performance, which is called also called a reconciliation. So let's go through these topics very quickly. So yeah, React follows a component-based design. That means like your system is made of a collection of components. So, and these components are like reusable, encapsulated, and cohesive components. That means like these components work together to fulfill a single well-defined task. Those are like loosely coupled components. And also, each component has its own interface that it communicates with other components. And also, a component can be extended without needing to make like internal code changes of the original component. So JSX. So with JSX, you can build UI templates in the app in the JavaScript side. So I mean, it's a syntax extension to JavaScript, and as you can see, like this is called a React component. That's because like it follows this particular function signature. It accepts like a zero or more, like no, like at maximum like one parameter. Also, it returns the JSX component. So although like we can build the UI using this JSX syntax, these are not actually like understand by the browser. So what React does is like it uses some Babel plugins like this one, preset React, and it transpile this JSX syntax to the code that browser can understand. Actually, you don't have to use JSX at all. Instead of, you can use this create element to create React elements. I mean, both this function and this function, that's the same thing. So about reconciliation. So basically a React app is a collection of React elements. So we create those elements using that create element method. So we can like represent it by this like tree structure. So this basically like virtual DOM is like a virtual representation of the UI, which is kept in the memory. So basically those are like bunch of JavaScript objects. So what a reconciliation is, let's say in the initial upload, React generate this virtual DOM. Since there's no like actual like browser DOM, it creates the UI, the actual UI first. And let's say later you change the state variable of these components. So then what React does is like it creates a new copy of the virtual DOM with those changed values. Then it runs like a efficient define algorithm and it identifies the change components. And once it do that, it moves the changes to the actual UI. So it does it like, I mean, in a like efficient way. I can even show you a quick example of this re-rendering stuff. So here I have like a simple website built purely using JavaScript and HTML. So if I open that in the browser, it will like simply update, show a timestamp. It will like every second it will update the UI. If we set the UI, the elements, you can see this. Let me show that. So you can see I have like a set interval, and every 1 second it updates this element with the current time. So it sounds once a second. You can see every second these are all the whole form it changes. That's because like it's based on the actually the way we are doing it. Because like every second we completely change this component. I mean, oh, yes, like if you want to fix that, you can like simply update only this value of this span. But when your applications are bigger, like it's very hard to do that. Also, like let's say you are like updating your UI like every 100 milliseconds. If you refresh the page, you can see it's like updating the page very rapidly. Can't like even see the updates. I mean, for a small app, it will be okay, but when your app, the website becomes very big, it will create like all sort of performance problems. So that's why it's important to use a framework like React. So if here, like I have created a sample React app, and here I have added some bunch of elements. You can see this is the root component, and inside I have like multiple components. So to explain this JSX concept, you can see this is like a individual React component. You can see here like accepts, let's say, name. You can see this is like a XML kind of template, and even in that one you can include some JavaScript stuff like this. So when you compile the code, that Babel plugin will convert it to something like this. So it removes this JSON stuff, and like it will replace this with this create element. React will return this object. So you can even like see that element if we also look at one, let's say we are passing the name as picture, and let's run that. So if we can open this console, you see this is the rendered, I mean, this is the element in the virtual DOM. It has like all the details about the type of the element and the properties and the children element, child elements. So I have, yeah, I have the same code to like update to show the current time here. You can see if I select that element, like once a second it gets updated. That's because like so let me change it to like 1000 millisecond. You can see the updates every second. Let's say by mistake I change it to like 100 milliseconds. What happens like on the other cases, like it was like pre-rendering the elements very quickly, but here you can see it still updates once a second, although you have like defined this interval as 100 seconds, because like although you run this code, you won't like actually change the value in a second. So React identify that, and it knows that although you run some code and although you're trying to update state, it never actually like it didn't update the actual value. So React doesn't update the UI. So although this React and React Native follows the same concept of React, so it's like the way how the virtual DOM gets converted to the actual DOM is different. But of course, like the business logic is the same. I mean, the same JavaScript stuff, but the rendering part is different. If you are building a website, uh, the React DOM is responsible for taking that virtual DOM and converting into the actual the browser DOM, the HTML components. On the other hand, what React Native does is it get the virtual DOM, and it has like a renderer called a fiber. Using that one, it renders the actual UI elements in the mobile app. So assuming that you learned something about React these slides, so let's see how we can like getting started with the React Native development. First, you need to install these dependencies. Actually, like I included a reference slide where you can like find these instructions. Actually, like you can even go to the React Native site directly and go to this environments setup section. So anyways, like I included some steps here. So for build an Android app, you can use either Windows or Mac OS or Linux machine. You need to install Node and Watchman, JDK, and the Android Studio. It comes with the Android virtual devices. Also, you need to after that you need to set up some like configure some environment variables like maybe Java Home and the Android Home. So to build the iOS app, you need to have like a Mac OS. So even there you had to install Node.js, Watchman, and the iOS the IDE, the Xcode. You can install that one, and after that you can install command line tools. And also for iOS projects, you need to install these Cocoa pods. It's the dependency management system. So once you have installed all these dependencies, you can like go ahead and create a empty React Native project. You can make use of the React Native CLI for that. So before that, like you can use that Android Studio that you install, and you can start a virtual device like this. So also like this React Native CLI gives you like a init functionality. You can create a blank React Native project with that. And also like you can pass this additional parameter. You can use a template for that. So I'm using a TypeScript template. I think it's better to use a TypeScript template because it gives you some additional type safety. So once you run that command, it will like create the React Native project for you. So I'm not going to like create that one here, do that here because it might take several minutes to create and initialize the repository. So I have already done that. So to show you the structure of a React Native project, this is the structure that you get when you run this command pm React Native init. So as you can see here, I mean, this is like very similar to React web project actually. You can see there's index in app.js. The difference is like here you can see this additional directories for these are the native projects, and in iOS you can see the index.js here and also the app.txt is here. So if you want to run the app, make sure the emulator is running, and then you can like simply run this command. It will start this Metro bundler and start a Metro server, and also like it will do the take care of the build process of the Android app, and it will like automatically open the your first app here. So as you can see here, like everything, all the components are inside this app.tsx It's so I mean, when you're adding like more stuff, you can't like keep adding those to this FTX. So you might need like a good folder structure. So this is the folder structure that I am following, and it worked. I mean, has been working for me very well. So you can like create a source folder, SRC folder, and you can put all your JavaScript stuff inside that folder. So you can like create additional like subfolders for like keeping the assets in that folder. You can like put all your images, SVGs, fonts, and translations there. And you can like create another folder for your commonly used components. I mean, the reusable components. And also you can like have a separate folder for keeping your concerns and enums and like stuff. And again, you can like define your types using TypeScript like in a separate folder called types, and navigation, or like although this is like a one page applications, like mobile apps has like multiple screens. You can like navigate from one screen to another screen. So for that, like to keep the navigation configurations, you can like create a separate folder. And also, let's say you have multiple screens in the application. In the first page, let's say you are getting the details of the user, and to the next screen, you need to pass those data. So to make things very easy, you can use this Redux for state management. So for that, you can like create the Redux folder and put all the Redux stuff here. And also like it's better to like keep your screens separately in a different folder, like this screens folder. And also you can like for additional like helper functions, you can create a helper folder and also a utils function. In the utils function, you can like put all the commonly used function such as date formatting or currency conversion, string formatting, or anything. So in the helper, mostly I use that for like for calling the APIs. So let's say you have two screens and both need to call the API to get the user data. So here, like in the helper, you add a service for that. It calls the API, and your two screens called this helper function. So let me show that the structure I created the other app. So here, this index is the entry point. So that is what like takes the root components and like here, like you can see, you get the app component which is exported from here, and you call this a register component and pass this one. That's what like create this UI. Here, like in the app component, you can like refer this stuff in here. You can see to use the navigations and using a function exported navigation stack in this navigations stack navigator class. Let me go through folders one by one. So here, like we can keep the images, SVGs, and translations. Here we are keeping the reusable components, for example, the login form. And if we are using like a screen title on multiple screens, you can like create it as a like a reusable component and put it inside, and can be used from anywhere in there. So concept, for example, you can keep something like this, an enum, and the helper function. Here, like we use the Axios to call the API. Here we have update user profile, and this one can be called from like different screens. Here we keep all the list of screens that we have built. You can see we keep the implementation of the screen in this one. You can see there are like multiple screen. The first screen is the welcome screen. You can see it in here. And for state management, we have the Redux store here. For example, I have created a separate store for keeping the user information called user reducer. And you can like keep all the TypeScript types here. Yeah, I have a type called user, the type definitions. And here like I have a date utils. Here we can like have a common use function called get current display time. You can like call it from any of your component and get the time. So that's about the folder structure. And so although like the app we build is like a very basic app, so for I think for like almost all the apps we need to use these libraries, because like all the apps we are calling a backend API as app like does not have only like one screen, it have like multiple screens. To manage that, we need to use this library called React Navigation. Also to use the state data across like multiple component screens, we need to stage management tool. In that, and for that we use Redux. And also like although you use Redux state management, when for example user enter his information and close the app and open again, so you need this data to be persistent, so you can use this async storage and Redux persist for that one as the persistent layer. And when it comes to the building the UI, React Native offers you like a built-in like components that you can UI components that you can use. I have listed some here. For example, let's say you want to display a text on the screen, you can use this text component. As you can see, I mean, as that even the name suggests, you know that this is component that can be used for displaying a text. You can have this image component, which can be used for displaying an image on the screen. Scroll view, you can like, it's a generic scroll container. Text input, you can get the input from the user, and the view, it's like a container for other elements. So if you head over to the React Native documentation, you can see all the list of UI components that it provides, like different components. And if it's not enough, you can like even use there are some third-party UI frameworks like I have listed some those libraries here. Native base, React Native Elements, React Native Paper. You can use one of these libraries. It will give you like a additional UI components. For example, let's say you want to show a drop-down element. Since React Native doesn't provide like a drop-down UI component, you don't have to build it from the scratch. You can simply use one of these libraries. So if I show you the code bit, you can see here I'm using, I mean, in a regular React application, you have these like HTML and sorry, divs, H tags, P tags, input HTML elements. But here, like we are using these UI components from the React Native framework. Like once you learn about these components, you can like similar to how you build a website, you can create a mobile screen. Also about styling, it's very similar to how you do it in the web. So almost all the UI components except the pop name style. So this style, you can pass a plain JavaScript object for that, or you can like even use a style sheet.create to create a style, I mean style object and pass that one. The only difference is like, for example, let's say the web, to change the background color, you have like background hyphen color, but in the React Native, it since those are JavaScript objects, you have to use camel case like this one. Again, let me show an example. Here, like we have this reusable title component. Here you can see it's just a text component. Here we pass the style object. You can see we have set the font size to 18 and text align center, font weight bold. I mean, this is very similar how you do it in the web. So it's like very easy if you know the CSS styling. You can like easily learn how you can do the styling in React Native. So I knew that like actually like I wanted to cover some more topics, but I knew that like even like covering these topics would take about an hour. So maybe I can do the rest in a future session. So things I want to like discuss in that session is like the metro bundler, like how React Native bundles all those JavaScript files and like create a one big JavaScript file. Also, like for the moment, like we run the app only locally in the emulator. But if you want to like send this app to someone else, or if you want to publish it in the Google Play or the App Store, then you have to create the APK and IPA files. So I'm going to teach, maybe in the next session, I can teach you how to build these APK and IPA files. And also like since, I mean, you write this business logic in JavaScript. So the runtime, when the user is running there, React Native needs to run those JavaScript using an JavaScript engine. So it's that JavaScript engine that React Native is uses. It's called Hermes. So I mean, maybe I can give an introduction about Hermes, and also the fabric. It's the renderer of the React Native. I mean, that is what takes that virtual DOM and convert it to the actual UI on the mobile screens. Also, let's say you're using third-party plugins and there's a like a new feature, the device use search for search for a plugin, but you can't find a plugin to do that certain native feature. So in that case, you might have to like create your own React Native plugin. So in the next session, I can give like a brief introduction on how we can build a React Native plugin. So yeah, that's all about the introduction to React Native.